All right, guys, welcome to PreCalc 315. This is day one of a two-day lesson. So we're going to be talking about solving word problems. So we're going to go over a number of word problems. These are very common ones which you're going to be seeing. Just kind of seeing hey, how should we approach these. So we're going to try these four today. So what I want you to do is try them out. Either you can do one and then watch me do it, then do the next one and watch me, or try and do all four of them, however you feel most comfortable. But go ahead and pause and do whatever you need as far as that goes, and then I will be going through the process for solving all of these. Okay, so 62 is a shared work problem. So on these ones, we're going to set it up by kind of doing ratios, right? So if we have like the first person is you have Jeff and Max. So Jeff can clean one apartment in 2.5 hours. Okay, so he can clean one apartment per 2.5 hours. So that's my rate there. So his rate plus the rate of Max, which is one apartment per 3.25 hours, is going to equal their joint rate, right? So this feels weird because you're used to like rates being per one, but it works the exact same way, right? This rate plus this rate is equal to their total rate, and their total rate is going to be one apartment per however many hours. Let's call it X hours, because I care about how fast can they clean one apartment. So I want to keep that one there. So to get this, I effectively just want to be adding these two things here, right? So if I grab a calculator here and I do 1 over 2.5 plus 1 over 3.25, right? I get 0.707 junk, right? So I get that is equal to 1 over x. So I'm going to want to multiply both sides by x, and I get that 0.70769 times x equals 1. And this is x hours. It's one apartment. So then, to get that x by itself, I just need to do 1 divided by that mess there. I actually just deleted it, but I should be able to still get it divided by the answer. And we get 1.41. So x equals 1.4130 hours. So again, the big thing there here that I want to point out is the setup, right? On a shared work problem, like see, like, hey, you know, how will it take two people to paint a house, to clean a room, to do whatever. Here's their rates individually. How fast can they do one thing together? That's what this kind of deal is, right? So it's the rate plus the rate equals the rate of the overall thing, right? And typically this is the thing you're going to be missing, right? So to set up the rate, go ahead and solve it out. All right, the next one, this is 63. 63 is kind of a word problems trying to say, hey, here's how some numbers relate. So we have two positive numbers, and their sum is 9, meaning if I add them up, I get 9. So that's one important bit. Okay, what's the maximum product that will result from the first number and the square of the second number? So this is actually an optimization problem, because we're looking for, hey, what gives us the highest, right? What gives us the maximum product? So product is if we multiply them. So this number times this number, what multiplies to be the biggest thing possible? Now, what keeps that from just being two massive 9 numbers is that the first bit, they have to add and be 9, and they're both going to be positive. So if I call the first one x, right? The second number is going to be equivalent to just 9 minus x, right? Because if they add 2b9, 9 minus the first one is the second one. So this whole thing here is my second number. And here is my first. So I know that they have to add 2b9 because of this. And now their product, this times this, I want to maximize that. So I'm going to say that this is equal to y, and then let's go ahead and graph it. So if I pull up a Desmos graph here, and I graph that, x times 9 minus x. I forgot one important bit here. It is the second part squared. Then what's the maximum product of the result of the first number and the square of the second number. There we go. Okay. So I want to square that second number, not just leave it there. There's my cursor, right? So to the second power. And now I get this graph. So if I zoom out, I can see it right there, 3, 108. So x is 3, the result is 108. So if the first number is 3, the second number has to be 6, or you could do 6 and 3, you'll get the same result either way. So my numbers are going to be 3 and 6. Awesome. Okay, so back over to this. Number 4, we have a mixture problem. So you're going to see these very often used with like alcohol solutions, because that's a very common place to see it in kind of a chemistry setting, right? You are going to want a specific percent of alcohol in your solution. Now they don't sell alcohol solutions in like bats of like here's 1%, here's 2%, here's 1.73%, here's 2. Like they don't sell it in all those different AMLs because that's dumb. That's a waste, right? So they'll sell it in like, hey, here it is in like 3s, here's in 10, here it is in 5, and whatever it is, right? So oftentimes you need to mix to get your own. So that's why you're going to see that kind of context for most of these types of problems. So we need 200 mils of 5% solution, right? We currently have 3 and 10%, so how much of each do we have to mix together to get that 5% we are after? So let's take a look at how we can approach this. So this actually ends up being a system for us. So on that system, we're going to say we have, let's say x is the amount of 3%, and y is the amount of 10%. I'm going to define that first so that I don't make errors going forward and mix things up. So that means that if I take my amount of 3% plus my amount of 10%, which is x plus y, I need 200 mils total. That's probably the easiest equation to get out of it, but it's also probably one that people forget the most because it is so simple, right? So I need that. Now the other bit that I know is the amount of alcohol that I have in my solutions. So I get 3% from my x, so I get to do 0.03 times x. So 3% alcohol times the amount of my 3% is how much alcohol I am getting from my 3% solution. Add that to 0.10, which is 10%, times my y, which is the amount of 10% solution that I have. And this is the amount of alcohol from my 3% solution plus the amount of alcohol from my 10% solution has to equal 0.05 times 200, which is the exact amount of alcohol that I need total in my solution. So I really have an equation for a amount of liquid, and now I have an equation for the amount of alcohol, right? So now I do have that system, and I can solve this like any other system, right? I can do it algebraically, but we can also do this quite quickly on Desmos. I'm going to hop back over here, zoom back in this way, and I'm just going to graph those. So x plus y equals 200. And then I'm also going to graph 0.03x plus 0.10y equals 0.5 times 200. Again, I could simplify that out, but there's not really a need to. I zoom out so I can find where those cross. Try something wrong there. 0.03, 0.05. There it is. Okay, because it can't be negative, so that makes sense. Okay, this feels better. All right, so then I'm intersecting here at 142.8 and 57.1. So what does that mean? Well, let's look back at my problem here, right? I defined x as being my amount of 3% and y as my amount of 10%. So the x coordinate of 142.8 and my y coordinate of 57.14, or just 1. This is my x coordinate, here's my y, so this is my amount of x. So I need 142.8 milliliters of 3%, and I need 57, some rounding errors here, that should be a 9, yeah, 0.9, 57.1 milliliters of 10% solution. So that's why kind of having those really helps out to say, hey, here's what that means in the context of this particular problem. Again, you could have solved that out algebraically, but I totally am fine with you using a graphing calculator to solve these ones out. All right. Last one we're going to be looking at here, number 65. So this is trying to average on a road trip. So this one, we have a 250 mile per hour road trip. We average 50 miles per hour over the first 125 miles, and then if we want to average 60 over the entire trip, how fast do we need to be going on that second half in order to kind of get that amount there? Now, most people say, well, if I want to average 60, then I need to be going 70 because the average of 50 and 70 is 60 done, right? But it's different because when you're actually traveling, there's less time being traveled over that same distance, so it does actually affect things in that way. So we're going to hop over here, and let's set it up like this. I have, over my first 125 miles, I'm going at a speed of 50 miles per hour. Now I need to keep that same rate consistent for myself here. So I'm going to add, so that plus 125 miles over x miles per hour is equal to, I want 250 miles total over 60 miles per hour. Okay, so if we do a little bit of like units here, miles divided by miles per hour, the miles cancel, so it's 1 over hours, which is dividing by a fraction is multiplying by the reciprocal. So this unit just ends up being hours, and hours. So time driving this speed plus time driving this speed is equal to my time driving total. Right? So that's kind of why this ends up working out for us. So at this point, relatively simple algebra problem. It's kind of weird to set up, but once you got it, it's just solve it out, right? So if I grab my calculator, I can just go, well, 125 divided by 50, that's 2.5. $125 over x, I'll call that still, equals 250 over 60. This is 4.16 repeating. So I want to do, well, 2.5, this minus that 2.5. I get 1.6 repeating. So 125 over x equals that 1.6 repeating. So I then want to take this and multiply the x over. So then it's 125 divided by 1.6 repeating. And I get 75. And it's miles per hour as the unit, as I found there. So there we go. So again, they're ugly numbers because there's these fractions and decimals and they're not rational, right? But the mathematical process is not very hard here, right? I subtracted, multiplied, divided, done. Got my solution there of 75 miles per hour. All right, hopping back over here. So that is what we're going to be doing for today, right? So I just want you to think about which kind of of those problems did you have the hardest time with? What was the hardest thing to kind of figure out, and then how did you end up finally being able to solve that particular problem? Okay, then here is our homework for day 1. We're meeting 69 through 76, and I will talk to you next time.